Hi, everyone. Let's start settling in. We're a little past our program schedule time, so it would be great to have everyone around. And the output is also happening at the same time, so let me check what's up there. I think this should be fine. We shouldn't have, yes, I fixed it. Good. Okay. Welcome to the Kubernetes and Cloud Native Summer Special Meetup. So happy so many of you are here. I'm really hoping some more trickle in. From the past, we've seen that that's usually the case. We'll have pizza, networking, and break time after the first talk. We have 2 talks this evening. That's our usual program, and we're sticking to it. One of the most sentimental reasons why we're also trying to have this now is because this will be the last meetup in this office space. This used to be the Kinfolk office space. I don't know if you guys have met Chris, but Chris was here earlier, and yeah, he was the founder and CEO, and we're now part of Microsoft, but we try to have the community vibe going with all of these meetups, and we try to have that despite our connection, and also to foster our connection sometimes, because we are doing good work even within Microsoft. And yeah, but I do also want to thank Microsoft for the fact that we still have this office space for some time now, which used to be the previous office space, and we're quite delighted with the few meetups that we did put up here after relaunching it and rebranding it post-pandemic last year. We've had 4 meetups so far in this office, and this is the 5th one. This is a call for anyone interested also in organizing or co-hosting or co-organizing some of the Kubernetes and Cloud Native Berlin meetups going forward. If you'd like to do this in your office space, if you'd like to get us in touch with anyone who would like to do it in your office, if you'd like to host, co-host, please have a chat with me. I'm around. Just grab me a little bit first for a few minutes, and we can have a good chat about it, and we can have an elaborate discussion later as well. Let's just get started with today's program, because I feel like we are starting with a little bit of a delay, but it's nice because it's summer, right? And I know it's been a little warm in the last few days, but we're very happy to have had planned this today. Weather looks good even later in the evening, so let's hope there's a little bit of a drizzle, but not much, and that you guys can also go out and enjoy the evening right after the meetup. We have 2 talks today, one by Hannes, the other by Rokas. And both of these talks are 30-minute sessions. We'll have a 10-minute Q&A right after. I've noticed a lot in our informal settings of meetups, which we also enjoy and cherish a lot. Something that comes up often is that when a talk is interesting and everyone's really geared up and they're really engaged into it, it can go on for a little longer. I just have to say that I'll have to be a little bit of referee there, and stop the talk at, once it crosses the 10 minutes or 15 minutes Q&A round. And you can continue to have discussions with the speakers even later. Feel free, this is your community meetup, and yeah, there are also a lot of giveaways from Cast AI and Microsoft. We have some community meetups and initiatives that we've organized. There are t-shirts and swag stickers from there, so feel free to grab them during your break. There's beverages in the fridge. Pizzas will be here in some time, but please don't be distracted by them. They will be there for you, and they are for your enjoyment. Yeah. There's one more thing I wanted to touch upon, and I just remember what that is. It's the code of conduct. I think we all know that, but it's good to reiterate. both from the community meetups perspective and from the Microsoft Code of Conduct perspective. We value diversity, inclusion, representation, and all of that, and everyone's opinion counts, everyone's opinion has value. Please be respectful. If you find that something's not really going in a specific order or is not respectful, please feel free to come and talk to me. We can have a dialogue about it, and we'll try and fix the situation. But the idea is to work together as a community and get through this and enjoy ourselves. This is for you, so yes. So without further ado, I'll pass on the torch and the mic to Hannes. Hannes is from Kubernetes, and he's going to talk to us about air-gapped Kubernetes. Big round of applause, please.
Thank you. All right, yeah. My name is Hannes Probst. I'm from Kubernetes, and Kubernetes, if you don't know the company yet, we are doing, or the biggest product of the company is called KKP. So you use that for multi-cluster. Yeah, run you through this a little bit, what it actually means. Few of the key learnings, I try to make this a bit bigger for me so I don't need to go like this all the time. Exactly, so the benefits of air-gapped, running Kubernetes air-gapped brings benefits even if you don't have that clear requirement. And usually if you have a bigger installation, maybe the building blocks we're going to be talking about for that is or might be already in your architecture. And then some pro tips on the way. So Kubernetes air-gapped, the what? Air-gap means putting an air gap between your system and the outside. In our case, we're talking about networks. So you want to isolate your network by physically disconnecting it, or, I mean, that's traditionally the case, but now more and more we're referring to the case where you bring in a firewall, for example. So it's not really air gap, but in a sense, you try to get as close to an air gap as possible. That being said, so there are different flavors of it, let's say, depending on how strict you want to run it. You could argue that maybe you do an air gap later on, so during provisioning time of your nodes, you allow everything, or limited access, but to the outside there is access, and then you shut it down. So you make sure that during runtime, you're shutting it down, or you're air gapping your environment. I think the most sensible thing or approach everyone could do is to have an allow list and say, okay, I have a list of trusted sources and you can connect to all of these freely. And then the more strict your environment is, or the more regulations you have, then we're actually talking about a blocked or a properly air-gapped isolation case. But why? What are the reasons for running air-gapped? Security, stability, resilience, performance, and compliance would be, I think, the topics you have in your mind. Security, obviously, you want to reduce the attack surface to your system. If you shut it down, no one can access it. Problem is, of course, you can't access anything. And yeah, you want to have downloads only from trusted sources, so you can't just allow any download. Good reasons are also to improve stability and resilience. GitHub is not so reliable anymore, sadly. I mean, they can go down. Ubuntu mirrors are down sometimes. And also maintainers, there's some packages suddenly gone. If someone is an Node.js developer who remembers that small packages can, if they go lost, that have a big impact. You're gonna wonder why I'm getting into all the dependency stuff with talks to air-gap, but we will get to this. Performance is also a thing. You're depending on outside sources, so you're depending on their performance. And we remember when GitHub, Docker, included their rate limiting. Suddenly, you couldn't really spin up stuff anymore. And yeah, compliance. I mean, this this actually touches again back on the security part. You might run an environment which is under regulatory or has regulatory requirements. You need to have an audit log, what is actually accessed. You need to have a software bill of material. So you can't just easily run any Kubernetes. And this is actually where the reason why companies are coming to us and say, we're interested in Kubernetes, but we can't run this. Like, we can't run this on our premises. It's completely air-gapped. We have these compliance issues, security topics. So yeah, it would be nice. We would be interested, and all the rest of the industry is moving to it, but we can't. And then we say, haha, no, you should talk to us. Of course, there are ways to do it. So let's look at a typical installation. How does it look like? You start, as always, just with a simple Kubernetes installation. You're really happy that it runs and it scales and that everything is fine. And then you realize you're doing Kubernetes and everything is not out of the box available. And you're adding more and more dependencies to other repositories, most notably, of course, container image repositories. So Docker Hub is the biggest or most prominent one, but you soon end up adding to that. And the thing is that situation, you realize, okay, I need to be aware of these sources. I can't just download anything from anywhere. So how do we do this? How do we achieve an air-gapped Kubernetes installation? I would say there are 3 things to it, or actually 2 and 1 caveat. So you want to tightly control your sources. So you need to have some system in place where you can make sure that what you download is limited and screened and checked. I would argue, and happily to discuss this later, that you don't want to waste time and money on pre-baking images. There might be good reasons too. Let's get to it later, but I'd say, yeah, anyway. And then leverage instead custom provisioning logic. So how do we control our sources? That's the thing I mentioned earlier. Most likely you already have something in your enterprise architecture, depending on how big your company is, but maybe you already have a JFrog or an Access in place. Use that as a central store for your software, and then use that as an allow list. So in this case, you immediately have limited the access, and everything just goes through that store. At the end, you also then can use all of the features these massive tools offer. Vulnerability scanning, for example. Also, if SBOM is interesting for you, you can get this out of JFrog and Access. Harbor is getting, of course, more and more interesting for, I think, our community, but it's not there yet, and they're focusing on OCI. So if you need to provision machines and install, for example, Ubuntu or any other stuff, binaries, you need to look elsewhere. Yeah, now I'm making the case against pre-baking images. I know when you're talking about air-gapped into Kubernetes, people jump to the conclusion to pre-baking everything on there. You can do this, depends on your case. I would argue that you still need some logic to provision your machines, right? Like, so you still have some code which then goes, renders some cloud init and provisions your machine, so you already have that, so leverage this. Put everything in there and don't waste your time with pre-baking too much. You end up making things too fragile, depending on your environment again and your setup. Maybe you are in a bigger company and you have different verticals, different access to different other parts of your infrastructure, different access credentials. You need to save these images all over the place, so it adds up some storage and traffic. Things you need to think about. So sure, pre-baking some part of it makes sense. I would say mostly off-the-shelf image is good enough. But yeah, if you're pre-baking, really think about a good solid bare image, and that's and then the rest, all the conditional logic you might have, put that in your provisioning logic. And now we are there where it's getting interesting. If if you have, let's say, a static cluster and you're bootstrapping your nodes with Terraform, you have some remote exit code, some glue code you do yourself, it's still good enough, right? Like you can then take this and override every download URL pointing this to your JFrog or Nexus or Harbor if you're only using OCI. With COPS, you can actually override all the URLs. So in that case, you can easily just say all the downloads are going to or are downloaded now from the central store. And with Cluster API and also KKP, which implements part of the Cluster API, this is actually where you have the most flexibility. Because there you have a templating and a provisioner, which then takes the templating and renders Cloud Init for you. There you can basically say, okay, I want to customize this fully. I want to point everything to my central store. And at the end, I have all the Cloud Init and flexibility out of the box. So this is a bit how it looks like, would be looking like. So you have some template in your cluster, and you have a provisioner. So the template is where you have your custom bootstrapping logic. You can have a template per operating system. So we have customers who want to boot a cluster based on Ubuntu or RHEL or any of these. So imagine how this would scale in terms of pre-baking. Instead of that, we would have a template for each of these cases. So this is also the place where you could put in conditional logic. So you can give them the choice of which CNI they would want to use. Imagine putting this in your pre-bake image. Suddenly you have an image per CNI. In this case, you have a conditional in your pre-baking, in your bootstrapping logic. So there's a template somewhere in your cluster, and then you have the provisioner who actually knows how to talk to the IaaS, talks to the template, renders that to Cloud Init, or also Ignition if you need that, and then bootstraps the node from that. So this, I would say, is the ideal case, and yeah, this is how roughly it looks like for Cluster API and KKP. I don't know if you can actually see this. What you're seeing here is the Cloud Init, where I use the benefits of Cloud Init, which has a lot of modules. For example, here a yum repos module. So it's super easy to override yum or apt repos. Here I basically define the Kubernetes repo, Docker repo, and some other stuff. And what that allows me then to say in my Bootstrap script to just disable the default repo and then continue installing everything. And it's instead of going to the internet, it goes to my central store. Before that, obviously, I set up my central store, my Nexus or JFrog, and added repositories there, which is a bit tricky. You need some expertise in handling these beasts, but you most likely then buy support of these companies. I'm not endorsing them, by the way. But yeah, here's one of the first pro tips. I think it's quite nice, actually, figured out a bit too late, but with Containerd, you can use their mirror feature. So you can actually, on your node, say, here's a mirror for all the image pulls. Instead of going to Docker hub /_/Redis, go to my central store. This is how it looks like. And this is the only configuration you need on your node to limit access to the internet and instead route everything to your central store. And the cool thing about this, and that's supported by Nexus and JFrog. No, sorry. Yeah, I'm getting to the grouping, but this is actually, the good thing is that the path structure of container registries are homogeneous. So everything in front can be changed, and then the registry resolves everything for you. So no matter what URL is used in your pod definitions or in your Helm charts, that doesn't need to be changed. So you don't even need to mention this to your teams. They can continue pulling or using their image URLs, and then this makes sure that it's gonna be pulled from your store. And additionally, what's really cool is that you can group repositories. It's at least for OCI repositories. Um, that's not something I saw for Harbor. I'm not sure if they implemented it. It would be nice, because then you can basically say, I have all of these repositories in use by my teammates. Most notably registry -1 Docker IO, Quay, of course GCR IO. And instead of having a repository URL handed out or configured in this mirror configuration, I can configure a group repository, ending up having a URL pointing to that group repository, and that's my URL I can use internally. Another cool thing is that I can then have an internal hosted registry. Okay, you don't see my mouse obviously, but here it is. And then also this is then grouped here. So all of the containers are accessible behind one URL. Okay, so now let's go into how an architecture actually would look like. I was talking a lot about this artifact store, and I think this is actually really crucial here. So first of all, though, you want to introduce strict firewall rules. You want to make sure that from your environment where you run Kubernetes, it really only goes to that one place. So you only is able to access the artifact store, ideally really that one URL you configured. So if you have a team managing this firewall, it's easy. You really just need to ask for this one access. Then you need to manage the store. And again, like this can be a bit, coming with a cost, of course, but potentially your company already has that, so you can leverage this. And then you need to think about your provisioning logic. So if you end up having a lot of conditionals in your scripts and it become like in your homegrown scripts and it gets a bit out of hand, think about solutions like Cluster API or KKP. But the thing is, you need to understand that here, you could argue how air-gapped is this actually? Like the artifact store has access to the internet, and down here, I kind of, I can access a system or in an environment which then has access to the internet. So we have customers which are not happy with this or that's not good enough. So let's say there's a fully air-gapped or no air at all gapped case. And what you do then is, or what I would suggest you could look into is that you then have a replication. So the store up here, which could be your company-wide artifact store, which has access to the internet, you can use that, you configure all the repositories you need, and then you use replication and replicate your own artifact store down here. So there's a complete gap here. And your artifact store here is basically fed by a snapshot. The way you transport the snapshot, this is up to your security constraints. This could be a USB drive. So you're taking a snapshot from up here. Obviously, that means you need cache warming, right? So you don't have this pull-through cache benefit that you don't need to care what's needed when, because it's just pulls it once and caches it. You need to notice and then cache warm everything. And then you do the snapshot, save it somewhere, move it down there, and replicate your environment. And then the rest is the same. So you have your provisioning logic, which knows how to point everything to your store, and everything should be fine. Yeah, that's more or less it. I hope you remember that air-gapped has many benefits, even if you don't have those requirements. I would say that after you grow in size and your installation becomes fairly big, it has so many benefits that I would say it becomes a must, or certain aspects of it. If you run into these cases where provisioning becomes out of hand or you pre-backing images and you're not so happy, think about focusing some time on that, and get the most out of your store. So once you have that, use it for vulnerability scanning and so forth. And that's it. Thank you. Okay.
Can I quickly?
Sure.
We have 10 minutes for questions now, and we don't really have a system where we pass a mic around, as you can imagine. We're working with this, quite informal here. But as soon as you have a question, maybe you can be loud, because this is also being streamed for a live streamed audience. Maybe you can repeat the question on the mic, so everyone has the benefit of it. Take it away.
Yes, I'm curious on how do you handle just input data to the cluster and out. If you're air gapping everything, especially the repos, as you say, how do you move data in and out, useful data for the customer? So customer needs X changed into Y. How do you get that information through the air gap?
Okay, so the question is how the user or the applications running on the cluster exchange their data when everything is air-gapped. Well, that's actually a problem for our customers, but usually they run software there which is not necessarily going to the outside. So we are talking about software which handles medicinal data or really.
Something like simulation where you have a time situation where you start one thing, you send the data in, and you let it sit to run, and then you take out the data more manually. It's not automatic or through the internet.
Well, the data is, obviously not transported through the internet, that's true, but that might be an environment where all the systems involved, also in critical infrastructure, for example, all the systems involved are behind the same air gap.
Okay.
Yeah. Any more questions? Where's the pizza? Yes?
We have a customer sometimes that has not exactly an air gap setup, but edge nodes that lose connection for a long time
Right.
to cluster nodes. Have you seen these kind of setups? Do you have any general advice you can give do setups like this where basically you have worker nodes that in IoT setups often lose connection to the cluster or the API server the installation
Right.
as well?
Yeah, so the question was about edge nodes who lose connections. I would say that, this is a complete different case, right? Suddenly there is an air gap. For that, there are different tools. I think KubeEdge is a bigger project. I'm not super familiar with this, but we also have customers who looked into this. The good thing is, because of Kubernetes, the software continues to run, right? In those cases, you would then have something like a cache on the nodes, which saves the API calls and then replays them. Can't remember exactly what tool that was, but yeah. There was one more question here. Okay. Yeah.
I guess it's a very generic, classical question about cache. Then we have some stories or examples when you cache some images or artifacts,
Mm-hmm.
but they change, like the original one is pushed with a new version. People are expecting the cache one to behave one way, but it behaves differently. Are there many risks in these scenarios?
You're talking about the hard problem of cache invalidation, right? There's naming things and cache invalidation.
Yeah, but more about caching and validating,
Mm.
that you're really getting the most updated image.
Mm.
You can push an image with the same name, right?
True. This is where tagging is helpful, at least for OCI images. And then I would argue that as long as you pull exactly that SHA bit, then you should be sure that the container is what you want. Yeah.
Just to answer this question, do you actually find it necessary to specify the digest as well?
I think that, yeah. So exactly that, I would highly advise to always use the digest at the end. Yeah. If you do use latest, yeah, it can. I think in that case, it's not different than when you use latest and be pulling from Docker directly, for example. Well, yes and no. of, that's a configuration thing you can then do on the registry on JFrog, for example, Nexus. You can say how many times it should invalidate the cache and how you handle these kind of cases. So you can really tweak it depending on the case. But I think to be sure, I would always advise to add the digest. Yes. Yeah. So you're asking for the logs of your air-gapped environment, or right? I'm not sure if I understand the question correctly, because I mean, of course, if you want to get to the logs or anything in your air-gapped environment, you need somehow developer access there. So there must be like some VPN connection going. Yeah. And if you're talking about the access logs of what's getting pulled and what's getting accessed, that's something where this artifact store helps, especially for audit logs, for example. You can get all of this out of your Nexus or your JFrog or your Harbor. So this is actually quite nice. You can analyze this and can say, okay, why is someone trying to access suddenly this repository which was not whitelisted? And then you can have a process behind that. Yep.
I got just not really a question. What I got from your experience, because we were talking about cluster API and ops, but what about like using managed services like ETL? I guess I know it's like by definition not really air-gapped environment then, but do you have like experience with that and such environments where you can like, I don't know, apply your best practices or something?
That's a really good question. I haven't really dived into this yet. Would be interesting, yeah. There must be some cases for that, but I'm not sure if they allow you to fill with this. I mean, I just learned that you can somehow turn off the autoscaler of them and do it yourself, but not sure how you do it for the control plane, for example.
When you talking about moving the container images, this is only a small part. When you, I think the main part is to deploy the artifacts to Kubernetes. And I think how do you do this? Do you use the deployment tools like Argo? Because the main thing is that you when you allow a developer to deploy it by hand is still very risky. When you deploy it by script, which is somehow quality issue, it would be much safer.
So you're asking if the deployment method has any effect on the security aspect of this architecture. I would argue it, as I said before, it doesn't matter, because you configured your container D or your container runtimes. CRI-O offers the same functionality, by the way. You can limit that access, and you use that mirror functionality. So basically, on the node level, you make sure that containers are always pulled from your central store. So it doesn't matter where and how and what actually runs or starts pods on your cluster, and what kind of URLs they put in. It will always be pulled from your central store. Did that answer your question, or maybe I did not get the?
One part of the security is how do you configure the images? When you have the images in repository, you can
Okay. So you're talking about the actual applications running on Kubernetes and
So, with your deployment, do you mean the Kubernetes itself? How to deploy the Kubernetes infrastructure, or do you more talking about how to deploy the applications on?
it's both. It's both. So you want to download the kubelet, and you want to download core DNS and your application containers. So it's the whole catalog of artifacts we're talking about. So at bootstrap time and during runtime. Any more questions? Pizza's getting cold. No? All right, thank you.
We have refreshments laid out there, but my suggestion would be we have a slight delay with the program, so I think we can even, let me check, we can even come back at 7:45. That should be okay. Yeah? All right then, viel Spaß. it's time to come back in. It's time for our second talk. I request you to come and take a seat, please. You can still grab slices of pizza and beverages from the fridge if you like. This is absolutely informal, so please go ahead with that, no problem. I'd like to give a special word of thanks to Cast AI. I don't see Chris around, but he's the one who also brought some of the swag and the t-shirts behind. And today's meetup's refreshments are thanks to them, so big thank you to them. Would also be nice if you want to chat with Rokas or Chris later about the stuff they do, what they build. Yeah, that's pretty much it. There's some more members from the Cast AI team, but feel free to meet them at your own time and see how you want to go from there. One thing about all the refreshments, though, we were just joking about this. There's a lot, as you can see. We clearly predicted a lot more in terms of the headcount, but it happens sometimes. There's no perfect science to how many people would actually turn up. But please feel free to grab a box or two if you want and go home. Absolutely, like do not even hesitate, do not even have to ask. Just feel free to grab as many as you want and go. Give it to the community, give it to your neighbors. We are very happy to share, we're very happy to care, so just go ahead with that. All right, without further ado then, we have Rokas here. Rokas is going to talk to us about cost optimizations while working on the cloud. And a lot of Kubernetes-related topics as well there. So I'm also quite interested in understanding how you can actually, because this is a pet topic that I think that keeps coming up in lots of teams. How do you save costs, though? How do you save costs while cloud costs keep mounting? And yeah, we'll hear more about that from Rokas. Take it away.
Thank you. So, guys, having fun? Yep. So I'm Rokas Bilevičius. As I was presented from Cast AI, been like with the company from the birth of it, like was the second developer there, so a quite exciting journey there. But throughout my career, I have seen like many different roles, and like from SysOps, DevOps, monitoring, development, architecture, and now I'm engineering manager, so quite interested to see all the developments, like from hardware to platforming to actual writing software. And today I'll talk about optimizing Kubernetes costs and performance. Like my first interaction with Kubernetes was in 2017. It looks like yesterday, but it's 6 years ago, right? So hopefully it will be relevant to you and you may take something out of this. So yeah, let's start. So what is cost, and usually how do you get cost? Like you get a bill, right? And then you need to understand like what this bottom line is from what does it contain, like what for what do I have to pay? And maybe it's easier in a grocery store, but if you're on the cloud, and this is, cloud native meetup, so we'll be focusing mostly on cloud technologies, not on-prem or things like that. So it becomes a bit more difficult for some folks. So how many of you have seen a cloud bill? Could you raise your hand, like? And did you like go deeply into like how much your service costs inside all those? And like for Kubernetes, it's kinda, you don't get a line there in the bill. Your Kubernetes costs 2,000, right? It's more a bit different, as cloud is built from raw resources, like, and then you get a list of different kinds of those and many more lines and more lines and more lines. I'm not surprised that this guy looks like this. So what resources does Kubernetes use? So it's compute hardware, that's straightforward, nodes, right? And in cloud, it's network as well. Not obvious to everyone, but sometimes the bill explains you that there's a network there and you have to pay thousands for egress and things like that. Of course, there's storage, but today I'll focus mostly on compute and network. As I said, I'm being exposed to this in current role I'm in CastAI, and we are helping companies to optimize Kubernetes and their infrastructure. So all the strategies I'll be talking in this presentation would be more of the things that work in real life and that we are applying. I won't be doing a sales pitch or nothing, but you can take these strategies and do it yourself. There are many tools, open source tools as well, which help with different parts of those. And we can chat about specific tools later on, maybe during Q&A or networking time together. So let's maybe start from the simplest ones, the node utilization. So I'll give a pretty simple example, like streamlined cluster, 3 nodes. Each of those nodes have kubelet running. It has an overhead. That's the price you have to pay for having Kubernetes. And then you have pods inside those nodes. And by default, Kubernetes scheduler works against cost optimization. If you roll out a new deployment, create a new pod, scheduler will evenly distribute the pods throughout the nodes. So by default, there won't be any nodes that are empty, and you can just delete them. And you'll have pretty much with some deviance of usage equal distribution. So what you can do, you can compact the nodes manually or with some tools, or and just move few pods from one node to another. You can do it with calling the API of a node or drain a node, for example. That would be, I guess, the most simple example that you can just, okay, so there is unused capacity, I will cordon this node, drain, and will remove the node that it's not used. And in this example, 30% of your cost is saved, right? And this, I guess this is one of the biggest money pit I see people are just wasting, as we are setting up autoscalers that new nodes would be created when your application scales up, scales down, but the scheduler works against that, as it never makes those nodes empty. And as you can see in this graph, there's no compaction, active compaction enabled. It's easy to scale up. You get a lot of nodes. Your workloads are not using that much resources anymore, but you're still paying money, because at the end, you're paying for computers. But if we apply the strategy which I showed previously, it's very easy to go to this state. And this example even has a headroom of it's 10% maybe, that it will always have additional capacity available. So if you would create new pods. We wouldn't need, to wait for auto-scaling to kick in and add a node, and that's a few minutes delay. And it's not. We're building systems not to save money, but that we would work the way we want to work without a delay. But you get the drill, right? So I would say can easily give you like 30% in your daily routines if you start looking into what's happening here. That's easily achievable. Let's continue. So, instance types. Do you guys know how many instance types do clouds have? Anybody tried to count? Maybe any guess from the audience? 600. This is pretty close. And maybe you were saying about instance families, but so yeah, it's like 500-700 gap, and different cloud has different count. And selecting the exact ones that would make sense for your application is really hard, but it's also impactful. Like here we have different instance families, and there are, as you see listed, I won't repeat myself, you can read it in a slide, but and these are different instance families, and different applications utilize those families differently. Like if you have a CPU intensive workload, memory intensive workload, it's beneficial to select the instance that fits your application, even if the instance is more expensive, because your application will work faster. It will use less resources compared to different instance types, so the delta will be greater and the system will run smoother. I even remember one use case in our system that you can have a microservice which is doing several things, and you can identify that one part of microservice is memory intensive, another part is CPU intensive, and even change your architecture by observing, how your application is working, and maybe split it in two microservices, and then you can more efficiently scale them and select the specific infrastructure that they would utilize better. And when speaking about this, it's sometimes there is a gap between developers and infrastructure people. Like, and there's not, I wouldn't say friction, but when there are two parties, you need to spend energy to reach certain goals. So it's very good. I'm always advocating that developers would at least try to understand more how infrastructure works. So the end result, the whole system, would be done more like, how to say, advanced or sophisticated, that's the word. So going further, this is a example how different can CPU utilization become, like just by moving from general purpose to compute optimized. And I'm always more focusing on CPU than on memory when talking about cost, because CPU is much more expensive in cloud than memory. It's like 80 to 20 or 85 to 15% ratio what you pay at the bottom line between these resources. So always prefer optimizing on CPU than looking into that, and it will you'll achieve better results. I selected this. It's a random image. I just searched for something that represents what I saw in reality, like how we optimized my team's service. And the results were quite dramatic in a way, as in Grafana, for example, you would see like 10 replicas running on different nodes, and CPU utilization would be all over the place. Like one replica has much higher utilization, another lower, and so on. But when we looked into that and selected the instance types that fit the use case, then it was a flat line. It was much easier to tune the requests, for example, in Kubernetes. How much do they need? Because you know the performance of the CPU they are running on. Okay, so we talked about instance families. Let's bring it a bit more about architecture of CPUs. ARM is on a roll in recent years. Certain cloud providers are pushing this like a train for people to use it. So it's quite, and you can leverage that quite easily by building multi-architecture images. Like, for example, in Go, you can easily generate artifacts either for one architecture or for other, and similar to other languages. And if you instruct Docker to also build a multi-architecture image with those two artifacts, which support both, you can be more flexible in your Kubernetes environment by saying, you put a label on application that it supports both architectures, and then the infrastructure team can, use either ARM, either AMD64 architecture, and further on optimize that. Then I last checked the prices of different instance types. ARM is on a similar price level as AMD, but actually it does more work with the same cycles. So your performance will be better. You'll be paying around similarly. Why I'm also like ARM, like when I changed the laptop from Intel to ARM, it's not like a portable heater anymore. And I really like our planet. So I would, from that standpoint, it's, even not looking like as an engineer, but as a being more efficient and spending less energy on running the data centers. If that hits, that's another reason to move to ARM. Okay, let's talk about the next topic. I would call it elephant in the room. Now we were talking about, I was talking about nodes, instance types, and how to select the right one, architecture, and so on. But usually, we just put requests on application, right? And how do you put requests on your, maybe I don't know how many of you are doing that, but the ones who are, how are you putting the requested resources? How you decide how much an application needs per replica? Yeah? Well, I saw one example like this one, but it's a good starting point. There's nothing wrong with that. The bad behavior starts when people do not follow up on their decisions. So, if you put 6 CPUs and 10 gigs of RAM, and you don't check what's the actual usage, So then you're wasting money, and it doesn't matter that you selected, compacted the nodes, you know, well, it matters, you know, but you're leaving a lot on the table if you're not looking into this as well. And this might be, you know, usage at a time. Usually the recommendation is to set a bit higher if you want the best performance, you know. Sometimes it spikes, especially for memory. You don't want events and so on. But the general trend is like in the industry that you can reduce 50% of your expenditure by focusing on these things. Okay, so now we went through optimizing our nodes, workloads, but it's not the end of optimization. In cloud, there's a market, there's dynamics of data centers, and it's not like on-prem. I bought, you know, 20 servers, and that's the capacity. Like the list price of on-demand instances is clear. It's a list price. You can check that and so on. Most of the companies go, okay, we use a lot of them. Let's make a better deal. We are a great user of a cloud. Let's buy reserved instances. And one caveat with that, that usually most of them, we don't even buy the instances which makes most sense, because they didn't do a lot of investigation about the things which we talked previously. So the best case example would be, you know, understand what kind of infrastructure you need, and reserved instances on their own, it's a good investment. But you need to be sure that you will use all of them. Otherwise, you'll pay for nothing. But the third guy or girl, I don't know, spot in a queue is like way cheaper, 10%. But it comes with a risk if you just take it and use it without any additional effort. Spot instances or preemptive instances, depending on a cloud and how it's named, they can be taken away from you at any time. And depending on a cloud, you'll get indication on like you can get an event, and depending on a cloud, it will be taken like in 2 minutes, in 60 seconds, or in 30 seconds. But in the developer community, and I saw quite a few tools which help with that, and you can even code it yourself easily. Inside every node, there's a metadata endpoint in clouds, and the event I was telling you about, that you'll get that event in some advanced time, is being pushed to the node. So you can listen on it and act upon it. So for example, there's one generous in AWS, it's 2 minutes. So if you get the event, you spawn a new instance instantly. You can get even a new instance faster than the original one is being taken away from you. Google gives only 30 seconds, so it's a bit more tricky. Microsoft is around a minute or 90 seconds. So, you know. But there are ways how to go around that and have a reliable and way of getting those 90% savings, especially on the workloads maybe that are not that critical, or, you know, you can experiment with that, and if you start to feel comfortable that works for your application. I've seen development clusters or specific job clusters which are running 100% on Spot instances. And I'll give some use case examples at the end of a talk. So there's this spot drift, and it's not fun actually. Like you get a spot instance, yeah, 90%, and after a few days, it price increases. And why? You need to understand that spot market is like, you can call it like a stock market, or it's, you know, it's a market. It's a demand, there's a demand, and that sets the prices. So if there's more demand, data centers give it for list price, for on demand. There's less spot, we increase the price, and, you know, economics, or I don't know how to call it, but you know what I'm saying. So you need to remember that spot price is dynamic, and you need to keep tabs on that as well to have the results you expected when you started using them. Okay, so let's, for the last part, let's talk a bit about network and how it impacts cost. So there's an example of, a simple example that you have a Kubernetes cluster which is multi-zonal. It runs between 2 zones, and you have a deployments. You may specifically say that their pods would run in each zone, so you would have an HA set up, you feel safe, and if one zone goes down, another will work, unless it's in the same building and you get a flood, if you know what I'm talking about. So, and by default, Kubernetes like doesn't account for this when it's routing the network. You could get like random calls between zones, and even your application might not send a lot of data outside the data center. There might be just chatty pods. Simple example, database and backend service, right? If you're managing your database yourself, or 2 backend services and they're chatting between each other, and this can generate the same cost in your bill as for the compute you use, depending on the amount of traffic. But you know, computers are computers. You can do a lot of things with them, and people are smart. So, and we have smart people in Kubernetes community. So, like in 1.24, there was a new beta feature released called topology routing hints, where you can set up based, if all the, there's a documentation in Kubernetes. I'll show you in the next slide how it looks. So you could read around later on, but the main key learnings from it is that if all the conditions are right, like it's not, the services are not overloaded, ABCD, and there's many conditions, your pods will be routed to the pods in the same zone. So this is, as I said, not like very strictly controlled, but if all conditions are met, a happy path scenario won't seeing these costs at all. So keep an eye on that, and there's a lot of movement around the space currently in the industry. It's quite fresh. People start realizing that, you know, this is a maybe 20% of their bill and so on. It's and start optimizing on it. So expect new technology coming out in this field soon. And this is how the feature is called. You can check it out and how to configure it, and further on save some money. So as I said, some example use cases for the end of a talk. We actually use a CI/CD cluster, and we build it for our own, dogfooding our own technology and putting our CI/CD cluster on steroids and not paying for it a lot. So what we did there, we selected very beefy machines, fast local storage, a lot of resources on spot. So we automated in GitLab that we run our runners inside the cluster, and when a developer raises a PR, it will spawn jobs which will create pods in that cluster. Once we finish it, the nodes will be deleted. So it's usually when there's no jobs, there's no nodes, everything is automated. Nobody needs to think about anything. Low cost, high performance. So perfect use case. Machine learning jobs. We had one customer who was running like tens of thousands of jobs at a time, and one run would cost them like $500, and it would run for 3 hours, something like that. So we helped them move those jobs into spot instances. Of course, you need to be aware that your jobs should handle if the spot instance is interrupted, so it could continue the job and so on. But it slashed the costs of those job runs by 70% and reduced runtime from 3 hours to 2 hours because of more beefy machines. So it's not only cost savings, but performance as well. Dynamic workloads with HPA, for example. We talked with one participant in a crowd before the talk that you can have various business metrics based on which you can configure HPA. And if you have a powerful autoscaling, sophisticated autoscaler, which could, add nodes at the time it needed, you can compact later on the pods as well. Your cluster can breathe out and breathe back to the same size, and you would run at this performance you would like, but you wouldn't have it for 30% of a minimal usage. You wouldn't need that 70% overhead if you wanted to account for the peak hours. So that's a very good tandem of HPA. And development environments is also like very dynamic. It's usually used by the working hours, and if you're not keeping tabs on that, it could cost a lot. So to wrap this up, sometimes engineers get not orders but tasks. We need to save costs, go on, and you cannot code anymore right now. This is the important thing. But what I want to say that optimizing and engineering the efficiency in your infrastructure, and later on seeing how it works automatically and you don't need to do anything and you can code all the time and your management is happy with the bills you get, or maybe it saved you as much money that you don't need to let people go. Like recently there are a lot of layoffs and so on, so it's a quite important topic. Okay. I guess we can do a Q&A, but if you'd like to connect and continue the conversation, or you can find me on LinkedIn. You just need to remember my name. I was lucky that it wasn't taken. So, Q&A time?
You mentioned the right sizing of the nodes. So in your CI/CD example, you said you have to choose beefy nodes. How did you get to that conclusion versus choosing larger, smaller ones?
The question is that how did we come to the conclusion between beefy and small nodes? What I meant by saying beefy is the instance types and the amount of CPU we give and the storage. Like if you run a job for 3 minutes and the machine is taken away, you can select an expensive one and give, like, for a job 5 CPUs instead of 1 and wait for 15 minutes to finish. And the size of it, like how we do it, we do not think about sizes. We more think about instance families. And when you set up the autoscaler right, it will create the size on depending on the pending resources you need. Like if you have 10 jobs, it will create maybe 5 smaller or 2 bigger ones, and you can vary it on that based on the prices of the nodes, and just select the ones which make most sense cost-wise. Okay, so as I understand, the main question is, if you need to run a lot of compute, why are you optimizing? Just buy bare metal and run it as many times you'd like, right? So that particular use case it cost a lot because of how horizontally there were tens of thousands of jobs, and it was because of the data sets they needed to do, like many different individual calculations, and they needed to be done separately. But they are ran like maybe 2 times per week, sometimes maybe more often. And buying your hardware and storing it and maintaining it, but not using it the whole time, it also doesn't make sense. If we would run those jobs like 24/7, in that case, yeah, maybe it's worth doing that. But when you're constrained to that number of metal machines, what happens when you need, scale a bit, and you have more jobs when you need to, okay, we need another machine. I'll order it, we'll have it in 2 weeks. So, there's no right answer, but you should weigh on your use case and think about what may be laying ahead, so you wouldn't shoot yourself in the foot. Yeah, please. Mm-hmm. So Yeah. So not question, but ask is for provide some examples of how monitor resources inside Kubernetes. So metric server, you know, there's like I couldn't call it native, but it's some cloud providers. Azure comes straight out of a box with it for sure. For AWS, maybe you need to install it. As I remember, GCP, don't know if it has it out of a box. But if you have it, it's easily installable, and you can get usage metrics of your pods. And there are number of tools which will ingest that data. Also, you can have Prometheus scraping each node with node exporter, and you can ingest those metrics in your Prometheus and build some dashboards. Not even build it, just install a template. There's a ton of them. So actually it's like an hour's task to start monitoring your usage. Everything is at this state of art in the industry. You don't need even to build anything. Yep, please.
In terms of auto-scaling nodes, let's say how to auto-scale like efficient nodes with like, let's say all consumption budget, all the affinities, or like no failures. How to efficient like auto-scale the nodes.
Um,
Is there anything to do with the scheduler also? Because
could you add more detail for me to grasp?
I mean, like if we have like CPU, memory usage, and so on. Now we want to, optimize the cost and so on. So by assigning costs to nodes and free up space and so on. But in terms of very complex, let's say, setup, let's say we have a lot of auto exception budget.
Mm-hmm. Okay, so you have the question is how to manage auto scaling of more sophisticated Kubernetes setup, where you have many different applications, which one should go to more storage optimized or CPU optimized, and how you go all around those constraints. So Kubernetes have quite some different scenarios, and how you can utilize that. First, like the most simple ones were node selectors based on labels, and but node affinities and anti-affinities, taints. I would say, you can guide the scheduler where to put your workload and those affinities, anti-affinities may be strict or may be loose based on scheduling, runtime, and so on. So Kubernetes, I believe Kubernetes have many tools built in which help you with that. And based on the autoscaler you use, it might hook up to those configurations of your workload or not. In our case, like the one we are building, we are complying to all native Kubernetes tooling and best practices. And our goal is that you set what you want for your workload, and you don't need to care about the nodes anymore. Like our autoscaler will, based on I want that instance family and need that many resources based on these parameters, and there are many of them for sure. It will create capacity in your cluster on time. But the main point being Kubernetes has these guidances on where to put, how to help the scheduler put the workload, and for example, how to route traffic through DNS with topology hints, which what actually those topology hints are doing, they're just filtering the IP tables and through the service checking which IP is sitting, you know, in the same zone and just giving you that IP. So Kubernetes is hard, but it's sophisticated and has all the tools. You just need to know them. Did that answer question? Okay, thank you. So if you guys have any more questions, we can network here. We're definitely a lot of pizzas left and some beverages. So please let's hang out more. Yep. T-shirts, yeah. Don't forget a T-shirt. Thank you.
All right, guys. Thanks so much for hanging out for the second part of the session too. I'm sure it was lovely for everyone, and I know that people are always quite interested in a lot of the presentations here. But I also wanted to point out that Hannes had a very cool talk as well. I missed sections of it, but I was also like from the back of my mind also trying to pay attention from time to time. Yeah, feel free to network, feel free to talk more to the teams of CastAI, to Kubernetes. Yeah, we worked with Kubernetes before as well to co-organize KCD earlier and everything, so we had a great time with them, with those folks. Feel free to talk to them about a lot of the stuff. I missed the demo also when Hannes had submitted his abstract. I remember it was very cool because we read something like, how do you do it without the internet? And I was like, yes, this is going in. Absolutely. I just wanted to reiterate that we're always looking for volunteers, co-organizers, and co-hosts within the community. If you if you feel inclined towards hosting one of these or organizing one of these, please get in touch. My name is Benazir Khan. I don't know if you know it, but that's my name. I should have said that at the very beginning, but here we are. Yeah, feel free to talk to me today, or we'll connect via LinkedIn and keep the conversation going. Since it's our last meetup here at the Skinfolk office, and quite a few of us are quite connected to it, I was also wondering if you all would be open to a selfie maybe, and we can all take a selfie this side. Yeah, with Kinfolk at the background. And let me know if this sounds good to you, then let's just do it right before you can break out for more beers or more refreshments, pizzas, grab a box or two, and yeah, keep chatting with Rokas and Hannes. Thank you so much. Have a good evening.